A trigonometric equation is an equation that contains trig ratios or trig functions. In this video, I'm going to explain how you solve advanced trig equations. So the examples that I'm going to use in this video are a bit advanced, but the process remains the same. What you do first, you try to simplify your equation so that it contains one trig ratio. By this, I mean it contains only cosine or sine or just tan in that equation, and then you solve to get something like cos x equals to a, where a is a constant and x is the unknown that you want to solve for. You solve to have cos x or tan x or cos or sine x equal to something. Then you use the arc function to get a reference angle. You use the arc function to get a reference angle, and then you use the reference angle to get more angles according to the range that you're given. Your answer should always fall in the range that you're given, and you should exhaust all the possible answers. So let us go to our first example. I'm going to use this one as an example. It's cos squared theta is equals to 2 minus 3 sine squared theta. And our answer should fall in the range 0 degrees to 360 degrees. Now, we need here to start by simplifying this equation so that it contains one trig ratio. It does not matter which one you choose. I can rewrite this as cos squared theta plus 3 sine squared theta minus 2 equals to 0. I want to eliminate sine so that I have only cos. I know that sine squared theta plus cos squared theta is equals to 1. So I can replace the sine squared theta by 1 minus cos squared theta. And let me do that. So this is cos squared theta plus 3, 1 minus cos squared theta minus 2 equals to 0. Now I have one trig ratio, the cosine. I'm just going to simplify this function. So we have here cos squared theta plus 3 minus 3 cos squared theta minus 2 equals to 0. I'm going to rearrange the function. Then if you say cos squared theta minus 3 cos squared theta, you get minus 2 cos squared theta plus minus 2 cos squared theta. Then we have 3 minus 2, which is plus 1, is equals to 0. Let us solve this equation now so that we have something like cos something equals to something. This means minus 2 cos squared theta is equals to minus 1. Divide by minus 2 both sides. We get cos squared theta is equals to minus 1 over 2. So minus 1 divided by minus 2, this is 1 over 2. So positive 1 over 2. But we are not looking for cos squared theta. We want to have cos theta. So from here, we can conclude that cos theta is equals to plus or minus the root of 1 over 2, which is equals to plus or minus root 2 over 2. This is what it means. Now we have done our second step. We now have something like cos theta equals to something. I'm going to move from this step to the next step where I'm going to use this to solve for my angles. So let us put this away. Just open a new page. So we now have cos theta is plus or minus the root 2 over 2. You can separate this, which is what I'm going to do. I'm going to separate this as cos theta equals to plus or root 2 over 2, and the other one is cos theta equals to minus root 2 over 2. From here, I'm going to work both sides independently. On the left hand side, it means theta is equals to arc cos. This is arc cos root 2 over 2. Now I'm using the arc function, which is step number 3. So root 2 over 2. What I get from here is my reference angle. So this is theta ref. I do the same on the right hand side. It means my theta ref is also equals to arc cos root 2 over 2. In other words, and I want to repeat this step, whenever you're looking for a reference angle, use a positive ratio here. Even though we have minus root 2 over 2, just use a positive one. Obviously, the answer from both sides here will be the same, but there is something that you should know. On the right hand side, our cosine here is negative, which means we have the answers in the second and third quadrant. So here we're talking about second and third quadrant. Second and third quadrant. On the left hand side, this is positive. Our cosine is positive, which means our answers are coming from the first and fourth quadrant. This is important so that you can employ or you can use your reference angle correctly. Now we punch into our calculator to get the reference angle, which is arc cos of root 2 over 2. Arc cos of root 2 over 2. We get 45 degrees. So this is 45 degrees. I have here 45 degrees. Obviously, this is also 45 degrees. But what do we know? We know that to get our other thetas, our other angles, we use our reference angle. On the left hand side, theta, our reference angle 45 degrees, it's actually one of the answers because it lies in the first quadrant. This is our answer from the first quadrant. So theta here is 45 degrees. This is the answer from the first quadrant. I look for the other answer in the fourth quadrant. This answer will be 360 degrees minus 45 degrees. This is the other answer in the fourth quadrant. So minus 45 degrees, I get 315 degrees. So this is 315 degrees. This is the other answer. So on the left hand side, I'm done. I have all my thetas on the left hand side that fall within the range that we're given. They said it is from 0 to 360 degrees. So I'm done here. I go to the right hand side. The theta ref I have on the right hand side, this one, it is not part of the answers because it falls in the first quadrant, yet we know that our answers should be in the second and third quadrant. In the second quadrant, we're going to get a theta, which is 180 degrees minus 45 degrees. And in the third quadrant, we have another theta, which is 180 degrees plus 45 degrees, which means here, my thetas on the right hand side, I have 180 minus 45. So it is 135 degrees. The other answer from there is 180 plus 45 degrees. I get 225 degrees. I have exhausted all my answers. So from the left hand side, I got some answers. From the right hand side, I got some answers. I have to combine all of them because it was one equation. Now, what we're now going to write is our solution set. So we need our solution set. I want to emphasize here that when you're solving trig equations, you rarely get one answer. Your answers are usually like 2 or more. So you put them in a set that we call the solution set. Everything in the solution set actually satisfies our original equation. That's what we do. So our solution set says theta is equals to, we open the set, it's 45 degrees. I'm going to start with the smallest to the largest. 45 degrees, then we have 135 degrees, then we have 225 degrees, and the last element of our solution set is 315, 315 degrees. Then we close the solution set. This is the solution to the question that we had. This is how you solve a trig equation, an advanced trig equation. Now that we have our answers, I'm going to do another example of an advanced trig equation, and this will be my last example. Please pay attention to how I solve the trig equation. So we have here, I'm going to new page. So we have here 2 sec squared x minus 5 tan x minus 5 equals to 0. The first step that we should do is to ensure that we have one trig ratio. And we know something. We know that 1 plus tan squared x is equal to sec squared x. So where there is sec squared x, we can replace it with 1 plus tan squared x, or tan squared x plus 1. This is what we can do. So let us go from here. Let us move from here. Let's go down here. So this means 2 times tan squared x plus 1 minus 5 tan x minus 5 equals to 0. This step is very essential. It's very important because we are now expressing our trig equation in one trig ratio. This is a very important thing. Whenever you're solving trig equations, you make sure that you express your trig equation in one trig ratio. You're going to rely on your identities or your knowledge of identities. Let me simplify further. So we get from here 2 tan squared x. So we have 2 tan squared x plus 2 minus 5 tan x minus 5 equals to 0. Let me finish the simplification. This is 2 tan squared x minus 5 tan x. 2 minus 5, we get minus 3 equals to 0. If you look at what we have, it is a quadratic function. We now have what we call a quadratic function. Now we can solve this quadratic function using any method. For all the methods that we know for solving quadratic function, you may complete the square, you may use the quadratic formula, or you may factorize. You choose any method here for solving a quadratic equation, any method that you know. When I look at this equation that I have, I can easily factorize it. So I'm going to factorize. Please, if you don't know, or if you are not fast with factorizing, you can use other methods of solving a quadratic equation. So I can factorize this as 2 tan x plus 1, and then tan x minus 3. This is equals to 0. And from here, it means 2 tan x plus 1 is equal to 0. So 2 tan x plus 1 is equal to 0, or tan x minus 3 is equal to 0. So from both sides, I have to solve for tan x. So therefore, I'm going to use a different pen here. Therefore, tan x is equal to minus 1 over 2 this side, or tan x is equals to 3. I have done the first and the second step. In the first step, I converted, this is the first step here, where I converted the equation into one trig ratio. Then the second step, I solved the equation such that I have something like tan x equals to a, where a is our constant. Now from here, I have now to solve the entire equation. I'm going to separate my equations into two here, so that I have another side with tan x equals to half, another side with tan x equals to 3. So let me move to that stage. So we have here tan x equals to half, and on the other side I have, let me wrap this part. On the other side I have tan x equals to 3. Now let me do the reasonings that you should always do. That is important. I'm sorry, this is minus half, not half. This is negative half. Now, if we look at our left-hand side, the ratio is negative. It is minus half, which means we find our answers in the second. So we're going to the second and fourth quadrant. This is where we find our answers. And on the right hand side, our ratio is positive. This is positive 3. It means we find the answers in the first quadrant and the third quadrant. These are the quadrants where tan is positive, in the third quadrant. Now from here, I have to use the arc function to get my reference angle. Let me go for my reference angle. So x ref, it's x this time, x ref is equals to arctan. I don't use the minus half, I use a positive one, positive half. Then I will get my reference angle here. Just a matter of punching into your calculator, arctan a half. I get 26.565. So 26.565 degrees. This is my x ref. But now, is it part of the answers? No, it is not part of the solution, because 26.565 degrees is in the first quadrant. Our answer should be in the second quadrant and the fourth quadrant. What do we know? We know that in the second quadrant, x from the second quadrant will be 180 degrees minus our reference angle, so minus 26.565 degrees. That's 26.565 degrees. Then the other answer from the fourth quadrant will be 360 degrees minus 26.565 degrees. These are the two answers that I'm going to get from the left hand side. So what do we get here? 180 minus 26.565 degrees. I get 153.435 degrees. So it's 153.435 degrees. The other answer from the fourth quadrant would be 360 minus 26.565 degrees. I get 333, so this is 333.435 degrees. So I have exhausted my answers from the left hand side. I have now to go to the right hand side. I start by looking for x ref. So our x ref will be arctan of 3. Arctan positive 3. I punch in my calculator arctan 3. I get 71.565 degrees. 0.565 degrees. It happens that here in this instance, the reference angle is actually part of the solutions because it lies in the first quadrant. I just have to find the other answer from the third quadrant. So x is going to be 71.565 degrees. The answer from the first quadrant. Then in the third quadrant, it will be 180 degrees plus 71.565 degrees. So I just add 180 degrees plus 71.565 degrees. I get, this means here my x is 71.565 degrees and 251.565 degrees. I have exhausted my answers on the right hand side. Now I have to write now my solution set. So solution set. The solution set should contain all of these answers. So solution here, x is equals to, I open a set. I'm going to write them from the smallest to the largest. So I'll start with 71.565 degrees, followed by 153.435 degrees, followed by 251.565 degrees, and then the last one is 333.435 degrees, 435 degrees. Then I close my set. I now have all my answers. That this is my solution. All these four satisfy the original equation. This is my last example in this topic or in this video. Please subscribe to the channel. If you have any questions or any comments, just write in the comment section below. I will attend to them. Otherwise, thank you for watching.